Okay, so we'll go ahead and get started. There's a couple people watching, so yeah, I was. This is James, and I had Esteban reach out over Twitter looking for some interest on how to do a keyboard project. And right now, I'm working on my Anacro stuff, but I've built a couple keyboards for a couple projects before, so I wanted to chat with Esteban for a little bit to share what the steps that I would do are. So maybe something that he can look into for a bit, or maybe something to figure out before we have some more time to work on this. So, Esteban, do you want to introduce yourself real quick?
Hi, I'm a software engineer. I'm part of the Rust compiler team. I've been doing that for a few years now, and I work in the Rust platform team at Amazon Web Services. And yeah, I'm generally trying to make Rust as nice and easy to use as possible. And I do have, when I was younger in high school, I did have some, I went to an electronics high school, so I have some prior experience. I've burned myself with an iron. I've ruined clothes with a peroxide. So I'm really excited about going back to actually playing with something a bit lower level than a compiler.
Yeah, definitely. Yeah, I around the start of last year is I was in kind of the same way. I'd built some circuit boards for university and projects and things like that, but hadn't really done anything like 10 years. And after watching a bunch of people, starting to follow hardware people on Twitter and seeing them make boards and building stuff, I'm like, yeah, that'd be way easier than hand soldering some stuff. Because I've done some like hand soldering stuff, but it always takes me way longer than I think. And sometimes just sitting on the couch and designing it in a circuit board design program is way easier. So
Right.
I figured I'd share sort of how I would break down this problem in my process, sort of thing, or like if I'm approaching personal or work projects and stuff like that. Kind of give you the high level blocks that are going on, or at least how I would do it and why I would do it that way, and what hard things you might run into if you don't do it that way. And then stuff that I just definitely don't know. And then yeah, we can either dive into that or figure it out from there. But I figured it'd be good to have about a half hour chat about this because I think we can cover the super high level stuff pretty well.
Yeah, that sounds great.
Cool. So I'm gonna go ahead and share my screen just to have some notes, and I'll probably post this up on my lab notebook later. But like the first thing that I was thinking when you were asking is like listing the wants
Right.
requirements because you said you wanted a 60 key keyboard plus like the nav or control row, right?
Yeah, so I can show you exactly what I have right now. That's of course it's upside
Yeah.
down and out of focus. Let's see if actually if I disconnect it, I can maybe get it in focus. So this
There
is
you
what I
go.
have right now, and it works well enough. It's wireless, but as you could see, I use it wired at all times. And there are two main things that I want to change. Three main things that I want to change from this. One is it has the function key on the left. Yeah, right here. And in order to do movement, I have to constantly wear my pinky and do that in order to move,
Yeah.
which gives me some strain in my pinky. So that first thing I want to do is add a layer of keys on the left side so that I can add a function key next to the control so that I can use my left hand for that and just use my right hand normally, like I normally would.
Mm.
So that is one thing. The second thing that I want to do is I have a YubiKey and I have this screen connected to my laptop, and what I would really want to have is some USB connectors somewhere here so that I can just press on the YubiKey without having to reach for my laptop, connect and disconnect things. And the last thing, and I think it's probably the one that annoys me the most, is because I have to press the function key to move around whenever I'm not in Vim. It's very easy for me to press the key combination to program the keyboard, and that always makes me lose 30 seconds just getting back to a normal state. So the last thing that I would really like is to be able to flash the keyboard by modifying the code. but then have no choice whatsoever about reprogramming it live, because I never really use that feature. And I can see how it's useful, but it's not for me. So those are the three things. Like I want a similar layout. I want keys on the left. I want extra ports, and I want to be able to program it by writing code, not by pressing the keyboard.
Yeah.
And I haven't really seen anything out there that fulfills all of those things. So I thought, yeah, well, I can. Why not do it?
Yeah, exactly. Yeah, I've seen some 10 key lists that have those like extra rows over on the right, but not on the left. And so, I mean, there might be someone making a left-handed 10 key list or something like that. But
Right.
yeah, I think keyboards are one of those things that I've actually really enjoyed doing lately. I've actually done a couple of smaller keyboards, just because from like a hardware perspective, they're a lot of connections, but it's not that complex, and it's very
Right.
hard to get wrong, even if you get the circuit pretty wrong. So
Right.
they're actually really fun things to do. They take time, but they're actually not so complicated if we
Right.
can avoid a couple things. So I figured I'd walk through like what James's process for this was. So I see basically figuring out the layout, sizes, features, and things like that. Like, do you want it to be wireless? Do you not want it to be wireless? Like,
I mean, if it, I, I don't mind if it's wireless. I don't have any need for it. My experience with wireless keyboards has been that either they have given me way more trouble than it's worth, and at the same time, if I'm building something from scratch, I would want to reduce the amount of potential things for me to screw up.
hmm,
So if it's wired, it's fine, and it also gives me, in my mind, I may be wrong here, but it may make turning the keyboard into a USB hub easier. Uh,
hmm,
but I don't know. There may be something already out there, drivers. I don't know. Um,
yeah, yeah, it's interesting. Yeah, so like figuring those things out, but then kind of regardless of what you end up going with, there will be sort of designing the PCB, because what you'll probably end up doing is making like a big custom PCB that's the size of what you're looking for. There's
mhm.
going to be designing or finding an enclosure, so like the box.
Yeah.
There's gonna be writing the firmware, and yeah, I mean, I think those are probably the big blocks on that.
Right.
Um, the requirements gathering is always the fun one of figuring out those kind of things, and even figuring out like what kind of switches you are going to use and things like that. Um,
Right.
switches, swappable. So designing the PCB, and I should say designing and manufacturing, um, like designing the circuit itself. There's laying out the PCB.
Hmm.
There's getting boards built, maybe with assembly. Then there's final assembly of kind of things like, because sometimes you just have a lot of things like switches which you may not be able to get soldered, or a lot of the times there are manufacturers that will solder a lot of the parts for you, but some of the bigger modules or more rare modules, or like the more expensive parts like key switches, because key switches end up being like the biggest cost of the keyboard, surprisingly. um those kind of things you may end up needing to solder yourself. But I probably
Right.
also want to preface this, that this is what I would do for rapid prototyping. So like I want to make one, but I'm only going to make one, or maybe I'll make three or something like that, where there are certain corners I would round because it's more expensive, but $2 more doesn't matter when your quantity is 1, versus if you're making 10,000 of them, it might make sense to, round some corners to save yourself $2 or something on the cost of the hardware. But if you're making 1, you pretty much just want to optimize for, all right, I just want it to work the first time and it doesn't have to be perfect. And if I really want to redo it, I can. But so I do a lot of like rapid prototyping stuff where I'll only have time to make 1 of them. So some of my suggestions here would be that. So some of this is also figuring out what parts you plan to use. Things like existing modules, kinds of switches, USB functionality. And I probably do all of this, by the way, in a tool called Kicad. So I used Eagle way back in the day for designing circuit boards, but nowadays something like Kicad, this is what I learned when I picked it back up in like December, and I've just been doing everything in there because you can do like schematic entry where you design the circuit itself and maybe use some existing parts or even add footprints if you have any, custom parts. And that you can even do like all the wiring and things like that. And that will give you a list of things that need to be routed, where then you can pick like your size of circuit board or something like that. This is a keyboard that I did for like a little pocket laptop kind of thing, which has let me full screen this real quick. So this has like a full keyboard, but instead of like mechanical keyboard key switches, they're like little remote controller buttons basically, where they click, but it's a full QWERTY keyboard in a big thing. So this is actually really applicable because I basically built a keyboard circuit for this.
Right.
So yeah, then you'll be able to route the board. This will let you make sure that you have all your connections put together and things like that. And then pretty much all of these tools nowadays can just, in a couple clicks, export this into Gerber files, also with like the position of all the drills and the components. And sites like JLC PCB are really cheap nowadays. Like, I think getting 5 or 10 of these built cost me like $80 or something like that.
Right.
And they had essentially everything. Like, I had a little port expander chip that's doing all of the control of the switches. I'll show you here in a little bit, but like all of the diodes and resistors that are required for the keyboard, I can have that all built for me. So essentially all I needed to solder was 8 header cables or something like that, which makes things way easier, because I find that it takes me about the same time to hand prototype something as it does design it. And if I'm not in a rush and I can just be like, all right, I'll design it and then I'll let someone who knows what they're doing manufacture it, it's kind of like a no-brainer for me. Although I've ended up with now like 100 circuit boards where I needed 2 and I have 5 because they only do that in multiples of 5. But you can get like just the boards with no assembly done for like 10, 15, $20 if you're willing to wait a week or 2 for the boards to show up. And then you can also, for a couple bucks more, basically the cost of parts, you can get stuff assembled. So I use JLC for most of this, and there's some really good tutorials out there of how to go from like Kicad and all the steps you need and things like that, and how to like create a bill of materials where you say like, okay, I've got all these diodes, but what kind of diodes are there? And JLC will have a list of parts that they can manufacture for you. So usually what I do is I get like all the little tiny touchy surface mount stuff assembled by them. And then if there's something expensive, I'll just hand solder that because it's something special that they don't have. So like for this, I only have like a little I2C thing. So this isn't a full microcontroller that could do USB. So I'd have to treat this like a module and have the smarter brain part, like the microcontroller that you're actually going to be running code on and is likely to be directly connected to the USB. I would still need something like that. I have designed some other modules, but I also wanted to show you something I've done here, which I made a little, my wife does a lot of data entry stuff for, she does business analytics and things like that. So she does a ton of like typing of numbers all over the places, and she didn't have a good numpad. So I designed a little numpad keyboard where I did one part. I don't know if you can see this super well, but the black
Yeah,
circuit board underneath the keyboard, that just has all of the keys on it,
yeah,
broken up to a header,
yeah.
and also some LEDs and stuff on it. And then I just do all the control. I made a little circuit board because I didn't want to do hand wiring. And I have another very simple board up here that just has a breakout for an off-the-shelf like microcontroller development board,
Is
which are
that a
like
Teensy? No.
this is the WeAct Black Pill, so it's a
Okay.
STM32F411. So it's a like a 96 megahertz 32-bit processor that can do USB. You can kind of see it off to the side. It's got a USB-C port on it, and it does all of the
Right.
power control and things like that. So I'm just using this as an off-the-shelf, essentially processor motherboard sort of thing. So this
Right.
whiteboard is very simple because all I'm really doing is just going, okay, this pin needs to connect to this pin, and then wiring that up in the circuit. And then I just have to draw wires kind of like here, which keeps basically for less than you could buy all of these individual components. You can buy a board that's been manufactured and does work for like 5-volt control and talking over
Right.
USB and connecting and things like that. And that way you can just build much simpler modules, either in one or in multiple steps, where you can just keep the complicated stuff as an encapsulated module,
Right.
and then keep it from there to keep like the amount of complication you have to deal with. So this works really well for the microcontroller, where you may not want to like hand solder all of the clocks and the capacitors, especially if they're very tiny components or have a lot of pins on them. And sometimes it's just cheaper and easier to get something bigger if you're not really hurting for space.
Right.
Like feather boards work really well for that. I use the STM32F4s everywhere. But yeah, it keeps things simple and often cheaper.
Right. That doesn't make sense.
Um, so that's kind of the process of that. And you go online and you order it, and it takes like 2 weeks to show up. You give them the list of parts, and they send it to you. Um, and then, like I said, if you have to wire some like cables in or connect it to a battery or something like that, I often like end up hand soldering just a couple headers or like connecting multiple boards together and stuff like
Right.
that. Um, yeah. So then you need to do something to design an enclosure or find one, which means if you are buying one off the shelf, like I know I have one of those 60 key keyboards, and you can get those like plastic boxes with standard mounting points for like $10 off like AliExpress and stuff like that. But if you need that extra row of keys, you either have to figure out how to jam that in there or see if there's like a case that's designed for maybe a full 10 keyless or something like that, but it's only the bottom.
Right.
And you can figure out what to do with that. Or you can go kind of all out. Like for this board, I ended up doing laser cut wood. There are some websites and services where you can get like laser cut wood or plastic and do a much more like stack kind of design, where I don't know, again, how well you can see this, but like it's basically just a sandwich of circuit board as a case,
Right.
wood layer as a spacer, circuit board that actually has parts on it, spacer, circuit board. So like there's 3 circuit boards in here, but only one of them actually has components. And the
Right.
rest of them I just use like fiberglass plates to make nice little enclosures and things like that. Or you can like get the whole, instead of using circuit boards, you can get wood cut or plastic cut. I haven't gotten into 3D CAD, so I've never made like a 3D printer design, but there's a lot of stuff out there for that. So you basically have to pick a path of how much effort am I going to put into this build? Would I
Right.
like to learn 2D CAD or 3D CAD, or how to look at data sheets and figure out exactly where the mounting holes are and make sure my circuit board lines up with those mounting holes?
Right. Yeah. Honestly, I think that for the first prototype, what I would end up doing is just using wood and modifying it by hand, and just to have something that I can actually use and modify relatively easily. It's wood is fairly forgiven,
Hmm.
so forgiving. So that's probably what I would do first. After that, I don't know. Maybe I would go with something like what you were saying of laser cutting, either plastic or wood. I do like the sandwich system that you had. It actually
Hmm.
reminded me of an old record player my grandpa had. Had a similar thing.
Yeah. Very cool. The other thing that I can pitch here is that
Yeah.
a lot of my designs, yeah, I could do this one because this one is one that I just built. So this is a little LED panel.
Mm-hmm.
But what I do for almost all of my like very low volume stuff is I put Lego mounting holes on it.
Right.
Because like with this keyboard, the actual keyboard that I made, on all of the circuit boards, you can see there's like little Lego edge rails here. And when
Yes.
I'm trying to figure out exactly how big something should be, that's generally what I do. And I find that Lego is really nice because it's kind of heavy, like, but it's also not, metal.
Right.
So it's not terribly light, and you're sort of limited in your dimensions, but sometimes it ends up being way easier to build something custom, or like for the first prototype or something like that if you're not sure you're going to use it all the time. But yeah, that's my 2 cents, in that I'm very bad at mechanical design, and I cheat by using Legos as sort of a replacement for that.
Well, you know what they say: if it's stupid but works, it's not stupid.
Yeah, exactly. And then for firmware, I know that both of us work in Rust, so I'd say like your sort of three options are figuring out everything from scratch.
Right.
Then you could use an existing project for this. If you or whoever's watching this, if you're a C++ sort of person, there's a much bigger, larger project out there called QMK, which is a fairly modern embedded C and C++ project. I've looked into it and helped some folks look at it for customizing their keyboards. In Rust, there is a slightly more limited, but enough of the moving parts to do like layers and LED control and stuff like that. There's a project called Keyboron. And that is basically a Rust library where it uses the sort of well-abstracted drivers from the embedded Rust ecosystem, where you just go, okay, I basically have my business logic of the keyboard as a struct that I can just wire up in a pretty straightforward way. And then I just have to plug into it, okay, what are all my pins that are controlling key switches or LEDs? And then plug in like the USB device module, because in Rust we have sort of one portable abstraction, sort of like futures almost, of a USB driver, where there's sort of one trait definition and then everyone plugs into it in a different way. And that way, Keyboron, the crate, doesn't actually have to know whether it's running on an STM32 or an NRF52 or anything like that. So I really enjoy using that. It just has a good hardware abstraction layer. But like I said, the QMK has been around for a couple more years and has lots of like out of the box batteries for like web interfaces for reconfiguring your stuff and firmware updates and things like that. And Keyboron's going to be a bit more like, okay, it will get you keyboard management and you can do layers and it can do patterns and macros and things like that. I think they have like Rust macros or Rust things like that that allow you to define mappings with enums and things like that. So it'll feel pretty, I've gotten together like this D-pad is running Keyboron. Also, I have a full-size like 60 key keyboard that's running Keyboron, and I've posted about it on Twitter a couple times. But yeah, so I see these as being like the big steps. There's definitely a lot more detail in parts of this. Like
Right.
Step 1 goes a bit deeper because it's like, where do I find parts for a reasonable price? What standards are there? Like, what key switches am I going to find lots of options? Do I want LEDs? These kind of things, where it's a lot of like high level questions. And for me, I actually tend to have a bunch of projects like this that I just occasionally, when I get bored, I go through like either Amazon for parts or like AliExpress or DigiKey or people who make blogs, or like when Adafruit or SparkFun releases a new product and I'm like, oh, that's a sensor that I haven't seen before, or that's a switch that I hadn't seen. And I know Adafruit's been doing a ton of keyboard projects lately, so they might, sometimes it's nice to look at projects to figure out what parts are out there. What I did is I ended up kind of following that for a while, and I ended up picking like 2 or 3 different kinds of switches, and then I just bought one bulk buy of, okay, these are my low profile switches, and then these are my big full size switches, and I use that for a bunch of different projects, so I just have them on stock. And that works really well with designing the PCB, because once you've verified that, like, okay, this is my stamp for a key. So when I'm like doing my layout and stamping all the keys in where they go, I know that this will work because I've built 5 of these boards before, so I don't have to worry about like double checking all the parts. So you're using parts that you've validated and are familiar with, because hardware, unlike software, requires like a 2-week $100 compile button. So you really want to minimize the amounts that you get wrong and reuse stuff you have confidence in.
So not that far off from working on Rust-C then.
Yeah, exactly. Someone's saying they wish they had infinite storage space. You can sort of see it over here. What I've gone to for storage is mechanics drawers, because they have really small, like 5-10 centimeter drawers, and a lot of them, and most components are very small, or boards are very flat. So I just have a good compression algorithm for all the stuff that I have here.
Right.
But yeah, so I mean, like, you end up picking your switches, what kind of keycaps you want, if you need it to be fitted to a certain size to hit certain mounting holes and things like that. You'll design the circuit, and I could dig into like what a single key switch circuit works, or how like key switch circuits work in general. And then like different options you'll have for lighting and things like that, for if you want RGB LEDs or it to do something else. Then USB is an interesting one, because USB full speed and high speed, so like the old 12 megabit and 480 megabit, 12 megabit is very easy to design for, because 12 megahertz is or 48 megahertz or whatever it is very forgiving. You can design circuit boards without a lot of care and attention, and it will likely just work, because you could basically do it over a cable. It's going to be fine. If it's on a circuit board, it's actually going to be better, even if it's not perfect. So there's a lot of room for failure there. 480 megabit per second gets harder, where you need to start controlling that you've got like a pair that needs to be the same length on the circuit board, and like certain things are controlled and you don't design things wrong. And then I'll admit USB 3 just becomes way harder, because it's like that times 4. Because you've got multiple channels and they all have to be controlled, and you often need like special controlling ICs. And it's not impossible. I'll admit I'd be comfortable with the 12 megabit part if I was feeling brave on a certain day. Now, after having working for about a year, I might try and tackle 480 megabit, but not be certain that it would work the first, second, or third time, and I'd probably just avoid USB 3 at this point. So this is one of those points where figuring out what your requirements are is really interesting, because if a YubiKey will work at the really slow data rate, and you're fine with that, you'll probably be great. But if you want to plug in like an external hard drive into your keyboard and do USB 3 to back up some files or something like that, you are signing yourself up for a more challenging project, or requires you to think laterally a little bit.
Right.
So what did you have in mind for you mentioned YubiKey, which is probably going to be fine at the really slow data rates.
Right. So I know that USB 3 will downgrade gracefully to the lower speeds. So you can just have the USB 3 mount, but operate at the regular USB 2 speeds. So that is probably what I would target first. Maybe in the future, being able to have, being able to charge my phone from the keyboard, that would be nice, but it's not something that I need. So yeah, I think USB 2, 480 megabits, maybe the sweet spot for me.
Okay.
I probably don't need it, but it would be nice.
Yeah. So, there's that, and I'll mention that sometimes, especially for low volume stuff, sometimes cheating is good, and finding, like, going on Amazon and finding an existing like 10 or 20 euro USB 3 hub, that is relatively small and compact, and figuring out a way for the case where you can basically take the USB hub out of its case, so it's just a circuit board, bodge it on the inside of the case, or maybe like flipped out where you have holes in the case where you can plug into the USB, and maybe do something tricky like solder the keyboard onto the back of the USB hub. Or a lot of them will have ones where they have like 4 on the top and 1 on the end. So you might be able to put the 4 on the top pointing outwards, and then the one on the end, you just have like a tiny little 5 centimeter USB cable that plugs into a very simple microcontroller. So then you have a very smart, off the shelf, verified to actually work USB hub. And sometimes that's a nice way to cheat if you're only making one. You wouldn't want to make an
Right.
assembly line of that, but for you, for one, find one that fits your size and then just design your plastic or wooden house so that it's got mounting points where there should be.
Right. So I feel extremely validated now because I was thinking of shadow rig and something like that, and
Yep.
that was my original plan. But I was more concerned. So for the USB hub, I planned to do that. For the actual PCB, I was more worried because I could take an existing uh, layout and just add a row of keys, but I probably don't know enough today to make sure that the N key rollover works correctly and that
Mm.
I don't screw something obvious up just by doing it the naive thing.
Yeah.
But yeah, I would probably go down the route you were saying of slightly cheating. Um,
Yeah. There's nothing wrong with, like you said, if it's stupid and it works, it isn't stupid. And I'll admit I've shipped a lot of like projects where I had to, like, customers like, well, we want a demo in 6 weeks, and I'm like, is it okay if the box is like this big? And they're like,
right,
yeah. And I'm like, cool. So this is a Raspberry Pi with a USB, 4G dongle with a flash drive, and then like one little custom PCB that does protocol translation from the Raspberry Pi to some proprietary customer bus. And I'm like, as long as you're cool with the whole thing being like ugly like a brick and the size of a brick, I can do it.
right.
And for your own keyboard, maybe you make just a very Commodore 64 style, deep case.
I look for the longest time. I had a Microsoft 4000 ergonomic, which
Mm,
is bigger than my laptop, I think. So
yeah,
I'm not. It's not an issue.
yeah. Um, Yeah, and some of that goes back up in this step of like when I'm starting a project and just thinking about it, but I don't know the details, I'll find somewhere where I can order like 5 different kinds of keys or keycaps or look at designs online. Like a big inspiration for a lot of the keyboards that I've designed, the MNT Reform is like an open source hardware laptop that is being made from scratch in Berlin. Basically, it's a super small batch laptop manufacturer, but he puts all of his hardware design files online in a Git repo as a Kicad project. So for
Right.
like all of this, I actually was able to do these fairly quickly because I had just from idling on Twitter seen that he had posted this, and I was like, oh, I'll just buy the same keys that he uses. And he had a KiCad footprint for the key switch, and I could look at his keyboard layout and be like, okay, well, I know that this spacing will be reasonable.
Right.
And this is one of those things that are really nice for taking advantage of open source, of things like that, which is really nice to, when you're building your first one and you're not sure you got everything right, sometimes seeing that you're doing it the same way as someone who does know what they're doing is super helpful.
Absolutely.
Um, yeah, so I mean, I could go into some of the details of that. Yeah, the enclosure stuff I can share a little bit, and then writing the firmware. I mean, we could look at that, but um, let me go back to the last project that I was looking at because I can show you. Or do you have any particular interest between this list of stuff? I'm pretty happy to go down whichever rabbit hole you feel most or least comfortable about, or where to start, or things like that.
So I think that one part that I would like to dig a bit deeper is in the PCB design,
Hmm.
and I'm intrigued. So as I mentioned earlier, I my last experience designing a PCB was um, actually drawing on a board and dropping it into acid, but I don't know, and I actually used KiCad for a while, and I'm glad to see that the UI hasn't really changed that much in the last 15 years. Uh, it's like a warm, it's like a comfort blanket.
Yeah.
But I don't know. I honestly, I'm completely ignorant about how going from a KiCad file to, oh, okay, I'm gonna send the file to this company that you were mentioning earlier, PCB,
Mm.
JLC PCB, and
Mm-hmm.
okay, what do I send them, and how do I make sure that I'm not screwing things up? And the other thing is, I'm very rusty, pardon the pun. So I'm I don't know about what components to look for. Like
Mm,
I can probably look for a refresher and tweak an existing design, but I I am very likely capable of sending 12 volts to a microcontroller that expected 1.5,
yeah.
just by accident. So I don't know. Does that sound like something reasonable to dig into?
Yeah, yeah. Let me give you the. I'll do kind of another slice of the process that you go through.
Sure.
Um, so I mean, first for the keyboard, there's a couple parts you have to think about. I mean, there's basically going to be what is your microcontroller that's going to talk USB?
Right.
Is that going to be a chip or a module or something like that? Key switches or keyboards have a pretty well defined, like there's a couple different ways to do them and they have different benefits, but the good go-to that I would suggest is sort of this row and column approach,
Right.
where you have rows of switches. They are sort of laid out like this, and what each switch ends up being is, one of those momentary click switches, which when you push down, they're connected, and when they're open, they're not. Um, and you have these diodes here because what you end up doing is one row at a time, or yeah, one column at a time. You turn them all off. You turn one of them on, and then you check the outputs. And you know that because
Right.
only this one is high,
Right.
these will only go high if I've actually clicked these buttons.
Right.
So you could do this without the diodes, but then you might have certain cases where you'd be able to see that being high on another row. And that's where you get like the ghosting of things like this. So by having these diodes here, you'll never misread the key as long as you go through one at a time, turning them on. And you basically just have this nested for loop of like for each column, set it high, set all the other ones low, read, 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 set this low, set this one high, read, 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 read. And then you can basically figure out which one was pressed by scanning through the rows and columns.
And what is a reasonable frequency to scan through the columns of the matrix here?
Um, I'm sure there's a specific way you can figure that out. There is some maximum rate that USB will allow for keyboard, and I'm sure there is a number that I don't know. But honestly, something like 10 times a second would give you up to 100 milliseconds of lag. So 100 times a second would give you up to 10 milliseconds of lag, and 1,000 times would give you 1 millisecond of lag. If you were able to do a full scan at that frequency. Because you
Right.
might step through each of these much faster than that, but to do one full scan, you might say every millisecond.
Right.
And that also might change how you have these pins connected to your microcontroller.
Right.
But the nice thing about this row column is that you don't need one input on the microcontroller for each switch. Because if you needed 80 switches, your microcontroller may have 80 pins, but not a lot of them do, and you'll probably end up getting the more expensive microcontroller just to have a lot of pins. But
Right.
this row column basically gets you for the cost of X plus Y instead of X times Y pins. So basically, you can figure that if you take the square root of the number, that's approximately 2 times the square root of the number is probably how many pins you'll need, which is much smaller than total number of pins. So this is usually the
Right.
trade-off that both like professional keyboards and those keyboards sort of like this. So then you're sort of presented with the question of, I guess if you know this is the kind of circuit that you would build, then you have to say, okay, well, what kind of values do I need for this? Like, what kind of diode do I need? What kind of resistor or things like that? But mostly what I'm doing here is like, you can look up this circuit and find out those, and there's typically ways to calculate what a reasonable value for that is, or for cases where you're like, look, I'm pulling this value up weekly just in case things don't go well as planned. There's certain numbers like anywhere from 1 kilo ohm to 10 kilo ohms will likely be good for that, where you can say like, when you look at this design, someone might note that this is a pull-up resistor. You can look up what a valid value is for that and those kind of things, and then measuring how long it would take to do things like that. Then with the diodes, the purpose of this diode is to prevent power going backwards up this way, which would cause some backflow. And then you have to figure out what kind of diode you would use for this. And this is going to come down to like cost and performance kind of thing. So this ends up going in reading data sheets or looking on the internet for custom keyboard projects and just be like, if everyone's recommending the same one, or I find some design that works and it's cheap enough for what I need. Again, there's a lot of material out there, sort of like open source software, where it's not quite as collected in one place, but there's often people being fairly public about that, or just downloading the Kicad designs is often very easy. So a lot of this is just following people on Twitter, and when they build something and you're like, oh, I want to know how to build that. The nice thing about the open source hardware thing is you can just go look at that and sometimes even ask them on the internet why they do that. So, I mean, I think I just Googled like keyboard matrix layout, saw this, knew I had to have a diode that was kind of fast to make sure that I, didn't have to wait too long before reading the pin. And then what I did from there is I was like, okay, well, now I need to figure out what diodes I should get. So I know that JLC PCB has like a search box that says like, what kind of diodes can I get? And you could do the same thing on like DigiKey or Mouser if you were ordering the parts, but you'd pretty much go somewhere that would have the components. And a lot of the time that I know I'm sending this to JLC PCB, so I know anything that's on their list, I can pay them a relatively reasonable amount to solder it well and not have to worry about ordering the components and doing the soldering. So I might go to like diodes or like signal diodes, because you'll see a lot of these keyboards will say you need a signal diode or something like that. And a lot of the times what I'll do is they have these basic parts where they don't charge you extra to go get them, where they basically have special parts on the shelf. And whenever you make a design, anytime you make them go get the special parts, they charge you €3. Doesn't matter how many parts you put on the board, if it's 1 or 1,000, but because you made them go to the shelf, they charge you €3 or whatever. So a lot of times I'll look at this and it'll be like, oh, there's none. So then maybe I'll go back to search and I'll just look up like diode. And then I'll filter by on the basic parts list and in stock. And then I'll filter by the ones they have the most of, because I vaguely will believe that if someone's using a lot of parts, often that's a good signal that maybe I should be using that part. Right. And then I might see that like, or I might even sort by, they used to be able to sort by price, but I guess not. But I'd look for one that was super cheap. Like some of these cost a penny and some of these might cost, well, this costs like 1.8 cents. I might decide that that's pretty cheap. So what I might do is I can see that this part number is like 1N4148. And I don't know if this is a good diode for keyboards. So what I might do from here is type that in and keyboard and see if a bunch of stuff comes up. Because if people are like, oh yeah, you can totally use 1N4148 diodes for keyboards, I go, okay, cool. This is a good diode for keyboards. And at that point, I might download the data sheet and try and find the numbers. But a lot of the times for just the first filter, I'll either use diodes that I use in other designs. Right. Like if I use something for something out, I might just go look at that and be like, okay, well, how fast does it have to be? What does the voltage level need to be? Like if I'm using it with a 3.3 volt microcontroller, will it act like a diode at that voltage? Or does it only work for like 9 volts or more or something like that? And a quick look at the data sheet will give you that. But then you can look at this and you go, okay, well, I have this diode and it will have a package, which is a specific footprint for a kind of diode. And often when you go into Kicad, if you just want to see like how big a diode is, you can place a component, and that said it was a SOD 323F. And for like common parts for like diodes and resistors and LEDs and stuff like that, there will be just like a bunch of common parts that are used for that. And most of the time they will be in Kicad. Sometimes you have to install like the additional package repository kind of thing. Right. And this takes a while because I've downloaded a lot of extra components. I don't know why it has to reindex on every time I open the program, but yeah. But what I'm saying here, so if I was going to go just like, okay, SOD 323F. Cool, here's a SOD 323F. And I can just plunk it down on a circuit board that I already have. And I can be, well, let's do this in a place where it makes sense, where you could actually see it. So I might just like play around with this, where I will just put one of these on the board and I'm like, okay, so this is my diode. Right. And I know that I'm going to have 80 keys. Let me just copy this. Maybe I'll just go over to like a different part where a lot of times I'll actually do this before I design my circuit. And I'll just be like, okay, I know I'm going to need 80 keys. So I'll put one here and let's just copy and paste here. I don't know why these didn't align. And then I might just, like keep copy and pasting them until I have like 80.
Right.
I don't know why this is not aligned. Mysteries of Kicad movement. But basically, like, I'll end up with something mocked up that will be, like, imagine if you couldn't see any of the circuits that were actually done here. But I just placed all the components. And I might look at it and I might go, okay, you can see that if I was using diodes this big, those are a little bit bigger, or actually those are a little bit smaller than this one. So if I had drawn this up, I would have gotten something like this and gone, okay, yeah, I know roughly where I can put it. Or I might find that, like, these are way too big. Right. I need to go find a diode that is cheap, but is maybe a smaller format. And then I might go into, like, the diodes and figure that out, or just kind of keep skimming through the parts list to figure out which one you have, or go look for other people's keyboard projects where you go, oh, look, they were able to get 80 diodes in a fairly reasonable space. So a lot of this is just kind of like bouncing around through most popular options on everything. And right. Sort of you end up finding parts that you didn't know exist, and maybe you can just search by the cheapest or the most in quantity or something like that. So that's sort of like how I stumble my face through circuit designs that I don't understand, is like I sort of figure out what I want. I go and look at how other people do that, or like what parts make that up. Like I've got the row column switches, then I have to feed those GPIOs into somewhere, like a microcontroller. So I might look up like microcontroller key switch example or something like that. And then I figure out like, okay, they've got some resistors and diodes, and I understand why they have those resistors and diodes there. Now I need to go figure out which ones I'm going to use, and if I have Kicad going to be doing manufacturing for me, because I don't want to hand solder 80 diodes and 80 switches and 50 resistors and 2 circuits, because I can pay them like $15, 10 of which is parts. I'm going to do that because this is my hobby and I only have so much time. And then I get the parts in, and then I just have to start like stacking multiple boards that do like one thing at a time, so I can keep them all simple, if that does make them a little chunky. But that way, if I screw one of them up, I don't have to rebuild the entire thing. I just go, okay, like on this one, if I had screwed up the little red board, I'd be like, okay, well, I have my microcontroller thing working and I have my keyboard thing working. I can just redesign one of these, and this is really cheap. Right. And I just have to wait 2 weeks, which is unfortunate. If this was a business, I may not want to wait 2 weeks. But when the cost of spinning like just a plain circuit board is like $5 or $10 shipped, you just go, okay, well, I guess I'm doing that 2 weekends from now and not this weekend. And like, there's a lot of room to not blow your timeline on failure if you're okay with being a little patient. And sometimes it's cheaper to just build 5 of the boards with all the diodes on it and see if it works, because it might still only be like $30 for 5 of those boards with all the diodes already assembled on them. So if you have to throw that out, okay, that's kind of unfortunate, but it's not the worst thing in the world. Make sure you know how to do electronics recycling wherever you live. But yeah, I really blunder through a lot of this stuff and just spend a lot of times making things look pretty. And if I don't know why something is like that, I post it on Twitter, or I go like that, and there's usually a lot of helpful people, or they go, hey, I did this like 3 years ago. Here's a link to my Kicad project, and you can go look it up and stuff like that.
Nice.
And you'll end up picking up little tricks like, okay, I need pull-ups, so I can put these all on the voltage bus with connections here, and figure out nice ways to hop between 2 different circuit levels or things like that. Because if you can do 2-layer boards, they're cheaper, and you can pick fancier colors, because JLC will only do assembly on 2-layer boards in any color, or 4-layer boards just in green. So if you can keep your circuit simple and do 2 layers, you can choose some fancier options, and sometimes it's cheaper. And then it's also important to know that circuit board assembly has gotten really cheap, and you can order 4-layer boards for like $20 more. So sometimes, if it would be a huge headache to route something in 2 layers, treat yourself. Spend the extra $10. Get 4 layers. Then you can make the wires go anywhere. And it's like, do I want to fight a puzzle today, or do I want to make my life easier and pay $10 extra for it? That's up to you, what you get fun for in your hobby. But 4-layer boards are really cheap, and yeah, there's something to be said about 2-layer boards, but 4-layer boards are also sometimes just nice.
It feels like luxury, but I think it's the same. It tickles the same side of my brain that whenever I see a clone in my code, I want to remove it, but I know that it's not worth it.
Yeah,
I guess this is the same thing.
Yeah, some days you feel like optimizing those nanoseconds away, and some days you just want a really cool demo that you can post a screenshot to Twitter for, and it's good knowing what kind of day you're having and what kind of fun you like getting out of your hobby. So yeah. I think I did this one just because I think there was some weekend where it was rainy and I was bored, and I was like, how can I make this layout of all of the rows and columns coming from the switches on either side to come through diodes? And because I was going to use this keyboard with a couple different things, this isn't a microcontroller. This is a port expander. So it's basically like a serial port controlled 24-pin expansion port, basically. So you can wire the 24 pins necessary for the keyboard into here, because I end up having something like 5 rows with like 12 columns or something like that, just to keep the layout easier. And so those 17 pins fit in the 24 pins that are on here, even with some spares. And so the only thing that I actually need to connect to my microcontroller board is 2 serial port lines, 1 line to reset the expander if you need to like hard reset it, and then an interrupt pin so that the expander can say, hey, I just had a pin go high, in case you want to do some like hardware acceleration stuff, but you don't even... Right. The only things you really need are ground, power, and 2 clock lines. And so then if you're just using an off-the-shelf microcontroller, you can just go, all right, well, I'll just make like a little socket for the microcontroller on a board, and then I'll run 2 wires over. Yay, it was simple, and I can use the cheap, or maybe I can make the keyboard stuff expensive 4-layer, and then the little microcontroller adapter board is just a 2-layer or something like that.
Right.
I also have some stuff like LEDs and stuff up here, but I don't have LEDs under the individual keys.
And so you mentioned breaking out to the microcontroller. Do you have any recommendations on what would be reasonable, what would be overkill, what would be good enough but too much trouble, so better go for something bigger? What would you recommend for something like this project?
Yeah, for like a keyboard, the nice thing is, unless you're doing like super high DPI LED control or something like that, if you just want to talk over USB and be a keyboard, literally anything these days will work. So again, I'd probably do the same thing that I do in hardware of go, like I mentioned, QMK and Quiberon. So if you were planning on using C or C++, you might go through the QMK list, which has a list of all the hardware they support, and maybe go find one that's an open source project where they've published all of their stuff and things like that. And if it's using like an Atmega, you might know that will work with C, but might be a little harder in Rust. Whereas if you know you want to do it in Rust, you might go look at Quiberon and anyone who's published on like the awesome Rust embedded list keyboard project, and go use whatever they're using, because then you'll know that like if you wire it up sort of similar to them, it's probably going to work. And then you can figure out while you're still learning why they did it that way. Like, oh, okay, they connected the USB up like this with these pull-ups and these chips in the middle, and then, they used these kind of diodes for that reason, where, especially when you're just learning, there's good things to be said about finding other people who have succeeded and solved the problems for you, and then learning why they did that so you don't have to do it the same.
Yep.
But yeah, I know Quiberon has... I've gotten it working with the STM-F4, where this is a really nice little like $8 or $10 Cortex-M ARM Cortex-M one that will work really well in C or C++ or Rust. I don't have it handy, but I have like there's a company called Maker Diary that makes a kit called the M60, which is it's a full keyboard, like a 60 key keyboard. Um, and they use a Nordic NRF52 on it because that can do USB and Bluetooth on there. So you can actually like wire it up to do that. And I think they have Circuit Python and maybe QMK support. But I've also done a project where I've ported Rust to that, and I have Kiberon working on that. So I mean, like finding one of those, pretty much anyone that you can find that is a working project will probably be everything you need. And then figuring out how to program them and debug them and things like that might be a little extra step, because you'll usually need some like adapter for that, where maybe like this one has a USB firmware update where you can over USB push new firmware updates, but maybe you can't debug through it. So what I use on my boards a lot are like external hardware debuggers, which allow you to do things like make GDB connections or make logging connections and things like that. But there's also a ton of cheap hardware out there that you can use.
Right.
So for some of that, you can look at like Ferris's knurling sessions where we set up like all the parts with different kits, but you can likely figure out why we use each part and then, you know, how you can connect it up into those kind of things.
Okay. This is I don't know how much time you have, and I don't want to take all day, but this has been very useful.
Yeah.
Okay. Yeah, I think that the road I'm gonna go down is just cannibalize existing projects, and
Yep.
I will likely look at Kiberon simply because I like to make things harder for myself. But
I think sticking to Rust is actually making your life easier. I find it's way easier to, like, if you are comfortable with Rust,
right,
there's a couple patterns you pick up in embedded Rust and some things that you know, maybe you reach for Vex and you have to reach for a third-party crate, but we have those as well. So, like, there's a lot of, you'll find that there'll be, like, a little speed bump, but it doesn't feel like a totally different process. It's just still Rust, just with a different set of libraries. Like, if you always did databases and backend and you went in doing like WebAssembly and front-end development, you'd be like, there's a bunch of libraries I don't know here, but you can still use Rust up, you can still use Cargo Doc, you can still use all this stuff, so it'll feel pretty comfortable pretty quickly.
Yeah, no, and that's likely going to be very fun. It's just I likely don't need anything special that other keyboards haven't already done. So
yeah,
the likelihood of me doing a lot of development is low, and at the same time is I don't know if I want to spend a lot of time debugging my keyboard.
Yep. I understand that. I understand that. But yeah, it's one of those things that, like, basing it on existing open source hardware is really good because you're figuring out exactly how you need to extend it, and yeah, it's a good way to learn, I find.
Yeah, no, absolutely. Okay, no, this has been very helpful. I will likely keep you posted.
Yeah, definitely.
The rest of Twitter as well on what I actually do. I will probably, I don't know. I need to make sure. I already have a drawer full of microcontrollers. I have a couple of.
So you use one of those.
Yeah. So I don't know if at DNC 3.2 actually, like, one, I know that you can get Rust code running on it, but it's not great, and I don't know if it has enough.
It does, but they kind of take a very classical Arduino approach where, again, they don't expose the programming lines at all, so you have to use their bootloader chip. So you will lose out some of the nice things like deformat or probe run and things like that. It's definitely possible, but there's fewer people doing it because the experience isn't quite as nice out of the box for Rust.
Right. Yeah, no, I will probably try to stick to something, to some microcontroller like the Black Pill or Blue Pill.
Yep. There's both. The Blue Pill's an older one, the Black Pill's the newer one. So the Blue Pill was an STM F1, So
I see.
like a much older chip, and then the black pill's an F4. So it's
Right.
faster, it has more peripherals, things like that.
Yeah, I'll probably try to stick to something like that, and who knows, maybe I'll reuse those older microcontrollers for something else. But
Yeah.
I I'm itching to get my to burn my hands.
Yeah, definitely. And the reason I broke these up like this is because you can find a lot of material out there for like what are the best mechanical keyboard switches? Like what are all the
Right.
trade-offs where even people who are just using out of the box kits, you'll be
Right.
able to find a lot of the parts that are good for this, or even like searching through keyboard projects of like who's using what diodes or what resistors or what values and things like that, or what
Right.
microcontrollers and stuff, where you can do a lot of searching on this. How to do the actual assembly, there's a lot of really good Kicad tutorials out there, or Kicad tutorials out there on YouTube,
Right.
including like I've done one where I literally did design to ordering on JLC PCB before, and I'm sure there's a lot of other folks who have as well. And JLC has even tutorials of like if you're importing from Kicad or Kicad, here's exactly how you do export step by step, what you
Right.
upload where, how you have to correct it, and then like a lot of them just have knowledge base articles because so many people are using the open source tools these days.
Right.
The mechanical stuff is again like you can either figure out something off the shelf that's cheap to buy because everyone's using the same thing, or decide how crazy you want to be with Legos or 3D printing and stuff like that.
Right.
Um, and then yeah, there's a lot of open source projects out for that. So I wanted to highlight it like these steps because there actually is a lot of material, but I don't think you'll find one top level like okay, do this, search in all these different places, and you'll there's actually a really good path through it. So this is what I
Right.
was hoping this would be, and thanks for poking that out of my brain because this is something that I have gone through recently and never really wrote up. So this was super nice to sort of brain dump how I did it the last couple times that I designed keyboards.
No, I'm very. It's very likely that I will be rewatching the stream at some later time to try to refresh my memory. But this already has been incredibly helpful, and I'm sure that anybody else that is watching this and was maybe on the fence of doing this, I hope you also nudge them into doing that.
Definitely. Yeah. Let me know when you're going on Twitter or if you get stuck anywhere. And if anyone else ends up seeing this and decides to do it, send me a message on Twitter. So I'll probably wrap it up here. So it was awesome to talk to you, Esteban. And I hope you enjoy the beautiful scenery that you have all around you. And
Thank you.
yeah, looking forward to talking to you soon.
Yeah, yeah, as well, and thank you for taking the time.
Yeah, no problem. All right. Thanks everyone for watching.
Cheers. Bye.
Bye.